So let us have a look at the vertical structure in the atmosphere. Okay. Just imagine that the atmosphere is a cake. You cut it in half, you open it up and have a look at the vertical structure from the pole to the equator. So let's have a look how your atmospheric cake looks like. Okay. So just introduce you to some words. For example, there is the intertropical convergence zone. And this is the region where the heating from below creates atmospheric convection, a vertical updraft and cloud formation at height. Okay, at the tropopause. What it means is convergence, the word means there's a horizontal convergence of winds. And to illustrate that, it's just imagine that you build a house on the equator and you have a door that opens up to the northern hemisphere and one door that opens up to the southern hemisphere. So if you open both doors, a horizontal convergence means there's wind, there's air coming in from both sides. Okay, there are, in more precise would be, there is actually a surplus of air coming in. Okay, and this air has to go somewhere. That's the principle of volume conservation, and it goes through your roof. Okay, the opposite process is called divergence. Horizontal divergence means that you're sitting in your house and horizontally you actually lose air through there's air moving out of your doors, and that's only possible if you have air coming in from above. Okay? And this is shown here in these Hadley cells. Okay, there is a region where you have a downward motion. Okay, and there's a wind moving away near the surface. This is a divergence. In addition to that, you also have something that we call the polar front, and the horizontal winds are called the roaring forties. Okay, and this one and this one. That's sort of another look at the vertical structure and introducing you to the terms of convergence and divergence. Okay, more precisely the horizontal convergence and the horizontal divergence. Okay, and the intertropical convergence zone.